11, they want us to match each equation with a graph above. So how do we match the equations with the graphs above? Well, if you notice, 2 of them are logs and 2 of them are exponentials, where x is in the power zone. Anytime you have an exponential, well, these 2 are the exponentials, aren't they? Because they're rocketing up. And these 2 are the logs, log or natural log, I'll say, because they're not going up, they're concave down. So exponentials are always concave up, they're like a bowl turned up. And logs are concave down, they're like a bowl turned down. Okay, so now the trick is you got to know what E is. E is a special number, like pi is a special number, you know, pi is 3.14, blah, 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 blah. Well, E is 2.718, blah, 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 blah. So just remember, pi is a special number, 3.14. E is a special number just under that, 2 point something, you know. That's all you need to know. It's 2 point something. So what does that matter? Well, this is basically like 2, or 2.7, whatever, to the x. And this guy is 10 to the x. So which one's bigger? Which one's going to go up faster? This guy's going to go up faster. This was faster up. Let me kind of scribbling around here. This one's 10 to the x. So it goes up faster. So which one's going up the fastest among these graphs? This red one. This is 10 to the x. And this one must be e to the x because he doesn't go up quite as fast. Right? So the red one is 10 to the x. The blue one is e to the x because e is only 2.7 about. Now the other 2 are the log graphs. So how is that going to work? Let me do a nice tricky way to help you with this. Remember, logs and exponentials are inverse functions. So inverse functions, they reflect across that diagonal line. Let me write a note on that. Inverse graphs reflect across the diagonal line y equals x. So therefore, this 10 to the x graph, he's going to reflect to this guy. This guy's the same thing as him, right? Those guys are inverses of each other. So which one has he got to be? He's got to be log of x. Why? Because there's an invisible 10 there. Remember when you write the log word, the base is an invisible 10? Whoop. Not writing very neatly there. Invisible 10 base. When you have the log word, there's an invisible 10 base. And these guys are inverses. See how they match up right across the diagonal line, the dotted diagonal line from each other? So this has got to be ln of x because there's an invisible e for the ln word. And that goes with the e guy. And then the 10 to the x goes with the log base 10 graph. So there we go. So the green one here, this green one is ln of x. So the green is ln of x. And then the black one must be log x because of the inverse thing. That's a nice way to handle it. Inverse graphs, not just logs and exponentials, but anytime you have an inverse function, the graph is a reflection across the diagonal line. Number 12, match the graphs here. Okay, so how's this gonna work?